So that will be really cool because I'll talk about, the entire CI/CD pipeline and also about the security gates that are should be part of this pipeline and how we can embrace ourselves of doing that.
Okay, so the virtual stage is yours. Let's start.
Okay, cool. Hello, everyone. So as I said, I'll talk about, how to build a secure pipeline. And I would like to walk you through the process about how to build it end to end and like what come into the pipeline security phase, from misconfiguration to infrastructure as code, YAMLs, all CVEs, et cetera. And let's deep dive to this presentation. So, like very short, talk about me. So I'm in the past 15 years, I'm a developer, and in the DevOps industry, about 5, maybe more years. I'm practicing yoga, and I love watching basketball. And currently, I'm the manager of Armo engineering group. Armo is the mother and father of Kubescape, which is the open source product of securing the pipeline. We have like many stars on GitHub, and you can just drill down and check that out in your free time. So let's go through the pipelines that we have, and then we'll see how to get the security gate. So DevOps is a modern engineering have enabled us to provide a higher quality code at the greatest speed of introducing guidelines and check into our automated continuous CI/CD process. However, with security becoming more and more pressing matter in the critical zero-day threats arise, and misconfiguration are introduced production system, while at the same time as application and development process all move to automation and CI/CD pipeline, this becoming a critical point in time to enforce security validations and checks. We're all pretty much familiar with this diagram, but do we really know what's the goal of the CI/CD? Well, I took it, from resources. The main goal is how we can reduce the risk involved in deploying software, and we need to plan our problems ahead. And that's the main thing, how we are planning the problems ahead, not just in deployment part, but also in security perspective. And let's deep dive down. So I'm going to present, what are the main stakeholders in the CI/CD pipe, and then we'll drill down to how we're securing those. So, first, what we're doing as developers, we're writing our source code, our infrastructure as code, or the applicative code. We're writing the YAMLs, we're writing the Helm charts, we're writing, in Visual Code as IDE or any other else. We're writing Go. All those and many, many more. We are PRing it, right? Or putting it in our GitHub, Bitbucket, whatever you're using. And then we're going to the next step, to the CI/CD server, where we're seeing the GitHub actions, the Jenkins, Circus CI, etc., where we're building our application. Also, the artifact, after we are building our application, what are the registry that are stored? We are having here Docker Hub and Harbor, and Amazon, Google has their own. And eventually we are deploying that using Terraform, Ansible, Argo CD, and all that you're seeing here. And of course, by the end, we are always continuously monitoring our applications, okay, to understand what their status. And we'll get to it very shortly, because that's a very important phase, to monitor the application and also the infrastructure code maybe, in parallel. So what we're seeing here is the developers are rapidly shifting right. from code, we are in production by just a PR code review, and then we're there. And what I want you to get from here is while we're rapidly shifting right, and from code to production is very, very fast. On the other hand, we want to detect problems ahead, as I showed you in the previous slide. So basically, that's like the entire pipe, and we're going, the flow is a bit different. I mean, we're writing our code, and then it's split, right? We need to put it into our application repo, and then in the IaC repo, right? Infrastructure as code. And then he's making a pull request, of course, then he's putting it in the repos. And after the pull request and all tests are approved, we're going to build the application using GitHub Actions and Jenkins. Over there are also a lot of tests and a lot of steps. And when we're finishing building this application, we're storing the image, the final image, in our container registry. By storing that, Argo CD takes the image, takes Argo as a code name, but takes the image, takes the infrastructure as code, which says how to deploy it on our clusters. And I'll focus here on Kubernetes cluster, as you see. And then it just deploys all over the cluster with the same matter. Okay, and basically, what can go wrong, right? Like, it seems very nice, flow. We're all very much familiar with that. But yeah, there can be some security issues here. And where we're seeing it in a lot of places. But the main focus is misconfigurations in code, mainly in IaC. And also, we're seeing it in code verifications and warning. I can assure you that not all developers are paying a lot of attention of warnings in their code. We can see it even in typos. So talking about security, that's not the majority of most developers or DevOps. And we're seeing here in the dependencies and the import of the packages that we're not really familiar with. Right? I want to import some other package of Go or any other package that I'm using, then I'm not sure what's in it, right? Maybe it includes CVEs. If I'm using, for example, another database or something like that, then I'm not sure what's in it. Of course, zero-day CVE is something that we cannot really handle. And RBAC configuration violation. RBAC is a whole subject of how to manage it, but we can surely see who, for example, is a member of a master's group, and so on and so forth. And the last thing that we're having is the CVEs, well-known CVEs from our image, from the package that we import previously, and that's about most of the security pain points. But of course, there are some more. But don't panic, okay? Because we really want to solve that, and we want to be aware of those kind of problems. And what I want us to get from here is how to resolve it. Well, the shift left is a very well-known term. So yeah, in security perspective, we want to shift left. And what shift left is basically, again, from the resource like Wikipedia, the efforts of DevOps team to guarantee application security at the earliest stage in the development lifecycle, as part of the organizational pattern known as DevSecOps. So basically, we want to have the, in previous step in the pipe, we want to have like security gates, and we want to know what are the security pain points like from the beginning and not in the deployment phase. So when developers are rapidly shifting right, then security is shifting left, as I told you. And why do we really need to shift left? So I'm pretty much you're familiar with this graph, SDLC, like software development life cycle. And where I'm detecting bug in the later stage, it costs me more. So the same thing goes for shifting left. If I'm detecting the security issues, like in my cluster in development, in the deployment phase, then it will cost me more to fix it, right? If I'll notice this in my code, for example, then it will cost me less. So it's pretty much the same thing, and that's one thing of why we need to shift left. So remember this this diagram. I'll walk through all those items, and I will share with you some of the applications that I'm familiar of securing, each and every one of those steps. And let's start with the right side, okay? Because we are shifting left, so let's start from the cluster. What we can do in the production environment. So in the deploy phase, basically we're splitting it to two parts: the vulnerability in cluster and the misconfiguration in cluster, right? Because vulnerability, let's say I deployed Redis, okay, in my cluster. I'll show you in a minute. That's the Redis I deploy, and I scanned just the Redis, okay, not all my cluster. But what I see here are so many CVEs, about 100 CVEs. And you can see here that there are some CVEs that we need to fix, and some other that we can't fix. Doesn't have any fix. So we really need to go over all those CVEs and fix those issues in our cluster, because that's a gate for the attacker. About relevancy, we can talk about in a different talk, but that's another major issue. So first, we need to scan our CVEs in the cluster. Okay, which CVEs? How critical are they? If they're low, if they're critical, and the severity. They are like the main three that I'm familiar with is Claire, Aquatrivy, and of course Kubescape. And in the other hand, working on Kubernetes cluster, that means that we're working with Helm, with YAML files. Those are mainly the Kubernetes objects that we're deploying. And also there, we're seeing, I think like 80% of what we scanned, we saw misconfigured clusters. I mean, and here's like a major point, okay? Because we want to check that there are no misconfiguration. What is misconfiguration, right? So I can give you some examples from Kubescape, which is basically just a set of tests that are sorted by severity. But what we can see here is we can see which privilege container we have, resource limit, CPU and request, workload with critical vulnerabilities, etc., etc. And then by the end, we're seeing how risky is my cluster. So here I'm using my personal Minikube, so it's not that risky. But once I'm checking that, I can say for sure where and which resources are misconfigured. So let me go back. Here it is. So there are several tools that are checking for misconfiguration. The tree is checking it, MKKit, and also Kubench by Aqua, and as I showed you, Kubescape as well. So, we saw the first part of the deployment phase, and now let's go to the container registry. Also in the container registry, we're finding some others that are scanning the registry ahead. Of course, that should be part of your pipeline, right? Before you're deploying, then make another step of scanning the registry. Just put the link and the credentials if needed, if it's private or if it's public. And the main resources and main products that are doing that are Aquatrivy, Gripe, and CubeScape. Basically, I use all three of those. And if we're going another step, we're going through the GitHub Action and Jenkins. That's our CI/CD, builder, I can say that, or our server. And over there, we can just add another, if I'll take, the GitHub Actions, for example, we can take, just another GitHub Action workflow, okay, just to get another workflow and insert it to our, the full path, the full workflow that we're using. And we're just taking this step, adding it, and we can define a threshold, okay? If I'm having, 6 critical vulnerabilities, then, or even just one critical vulnerability, just, fail the pipe, and else, you can just continue. So those are the GitHub Actions example that we're having here, and also the Jenkins jobs, including, and there are several products that are doing that. OSA and like White Source, I think they just changed the name, and of course, as I mentioned, CubeScape. So let's really shift left. Okay, and let's go to the code perspective. And basically, what do we have in the code, in the source code perspective, right? We're having the applicative code, and we're having the IaC code. And there we can, we can scan our Git repo, right? The entire repo that we are PRing to. The PR basically can also run those tests. And in the IaC code, there are Trivy, Snyk, and CubeScape. And the applicative code, you can find SonarQube and Checkmark for checking CVEs mainly. Okay, less, if I'm not mistaken, less misconfiguration. Of course, the misconfiguration is mainly in the IaC code. And also, there are some source code security plugins in your IDE. For example, I'm using and I'm writing the Visual Studio Code, and we just created like CubeScape plugin that, here it is, that is checking for misconfigurations in my YAML, which I'm going to put in my dev, staging, and then production cluster. So what I see here, that just when I'm saving this file, I can see where I'm wrong, right? If I didn't define CPU memory limit, for example, then it pops up and tell me, hey, listen, check this warning. Again, we need to check the warnings, okay? It's from the previous slide. So as I said here, there are several products that are doing that. There's White Source, CubeScape, SonarQube, Checkmark, and the tree. And like at the end, we're continuously monitoring our applications. And you really want to monitor it continuously. And, there are many Prometheus exporters. It's very easy to create one. Of course, Prometheus is an open source project. And it's very easy to create. Again, the exporter checks your application. We created some exporter that checks, the cluster for misconfiguration and for CVEs, and then it can come up all the time and scrape your clusters in many other ways, not just security. But that's something I'm very, for it and sharing it. So, those are the main security gates that I want you to take from this call. I mean, we need to put in each and every one of those, each and every one of the pipeline, like security gates, in order to fine tune and find the problems ahead. You know, we started from that. We need to find our problems ahead. That will cost us less. It will be easier to solve. And when I'm putting all those security gates, and there are, as you saw, there are, you know, not quite of the product that are dealing with this matter. And it's very simple, you know, to add those steps into your pipeline, and it's very much important. So we want to have security gates in the production in our cluster to continuously monitor and check what is the security status in our cluster. And we do want to shift left and to find it in the container registry. Maybe we're using like different packages, right? I showed you before the Redis, for example, that has like tons of CVE. Maybe I need to upgrade Redis in order to avoid all those CVEs. In my pipeline, the CI/CD flow in the GitHub Actions, I can just add an action and say, hey, listen, in this matter, you know, don't pass the test, don't pass the pipeline, don't build my application. And of course, in our code, okay, I think that we can find there a lot of CVEs and misconfiguration, and be prepared before we're going to production. So, you know, I hope I didn't scare you, but, you know, risks are everywhere. We just need, you know, to defend from them. And, you know, as Kubernetes is, you know, in production for few years, and many companies are using it, then we need to keep ourselves safe. We see attackers that are learning Kubernetes and how, you know, how to get into Kubernetes. We're seeing, I think just yesterday, there were another 2 CVEs, you know, rising. So we do need to protect our cluster, you know, from attackers. And I hope this is what you're getting from this talk. I had a pleasure, you know, talking here. It's a very great platform. I hope I'll be there soon, and thank you very much for that. Bye-bye.